Under insert, my link is link CAD, right?
No, link Revit.
Okay, my link Revit is grayed out.
Okay, that's because you're in a view, you're in a drafting view.
Okay.
Drafting views are not the same as model views. So go to one of the actual floor plans. There you go.
Okay.
Yep. Good, origin to origin, very good.
Oh, shoot.
You're all good. Yep, go ahead and open that up. Very important. Probably the most important thing.
Yeah.
Okay, great. So you guys have them linked in. Remembering to do origin to origin. Hey, Scott, this is NYO FS2, CAD Department Test Project. That's where the basic ARC link. We're just starting from scratch here. I don't really care about the template since we're focusing on families for today. Okay. So then after this, what's the next thing that you do? After you link it in?
Pin it.
Pin it! Nice. Good job, guys. I'm going to grab it, pin it. Excellent. Okay, very cool. Scott, you're like that kid who is retaking algebra.
If he's loading, let's go.
No, it's there somewhere. Because we're back in here. All right. Oh, you linked in the template.
Right.
No. That's not what we're linking in. Okay. So we're linking in the ARC model. You linked in our actual template.
Okay.
Link.
Grab it.
Not template. We're linking in the ARC model. Right, the template, the template file is just an empty project with a template. Okay, there you go. And then we say it. Yep. Okay. Yep. Okay, cool. So now that we have this this linked up, what I would like to do is we're going to jump. So basically, those were just those preliminary steps. What I want to do is first verify that in this particular view, and it doesn't matter which view you're in as long as it's the floor plan that shows the model. Under VV settings, I want to make sure that electrical equipment is checked visible, air terminals are checked visible, and plumbing fixtures are all checked visible, because these are the three families that we're going to be creating and placing. Okay, so just make sure that those are all there so that we can, when we place them, we'll see them in the view. All right?
Electrical equipment, plumbing fixtures,
and air terminals. Yep. Okay. And then let's go to the annotation category under generic annotations and make sure that generic annotations are also checked. Good?
Yep.
Awesome. Okay. So last week, all we did was visibility, right? We did no modeling. We did no anything. Today, technically, we are going to do a little bit of modeling. We're going to be placing families in the model. We're also going to be editing them. So the first thing that I want to do is I want to bring in a receptacle, right? A standard duplex receptacle that is going to show here. Now, in order to do that, we're going to start discussing the Systems tab. So let's go to the Systems tab and quickly go over what this tab means to us. When we do Friday's class, when we talk about modeling, everything that we do is here. This is the equivalent of our AMA tool palettes in AutoCAD, right? Everything that you're going to drop on the page that's geometry comes from this tab here. So the first is mechanical, duct placeholders. You can treat duct placeholders as a single line equivalent of a full duct, and we'll get to the differences on Friday. Duct fittings, dampers, flex duct, air terminals get their own button because we place so many of them. Mechanical equipment gets its own button, air handling units, VAVs, rooftop units, anything like that. Then we get to plumbing, pipe fittings, blah, 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 plumbing fixtures and sprinklers. Here's where we get into electrical. We'll talk about wires on Friday, conduit, cable trays. Sometimes we model these. It really depends. Like if we're on a project where we have large conduits that need to get coordinated, 6-inch conduits, 4-inch conduits, we usually will route them. And they work really the same as pipe. And then we get to our light fixtures and our electrical devices and switch gear, panel boards, anything like that. So when it comes to families, the duct, let's call it family, is created by the program. We can't edit that. We can't really edit to make a hexagon-shaped ductwork or a ductwork with, I don't know, like flanges on it, right? Like those are all system created. There's nothing we can do about that. Duct fittings, duct accessories, air terminals, mechanical equipment, these are all families that we can create. They're real things, right? Like duct is just this thing, and we say it's either rectangle, oval, or circle. Everything else is something that we can create geometry for. Same goes for fittings, pipe accessories, plumbing fixtures, sprinklers, we can make, pipe we can make. Conduit we cannot make. Wires we cannot make. Electrical equipment, devices, and fixtures we can make. So you kind of get a feel for what we can and can't do here. Dry erase. Could be. Just check in here. Okay, so when it comes to families, the overall, you know, when you take biology class and we talk about family and phyla and genus and all of that stuff, we can treat families the same way in the sense that the highest category that something can be classified is the family category. And what that does is when we create a family, we define if it's a duct fitting, an air terminal, a mechanical equipment, right, anything like that. Not in there? I can draw. Why would it not be like right here? Who would take these things? Oh, you know what?
No, you.
Go ahead.
Okay. You check up here, nothing there.
Mm-hmm.
In that cup, nothing.
No. There is a dry erase marker. Okay, I'll work around what I see here. That's fine. Doesn't work. Okay. All right. So the top tier is the family category. Okay. And when we create a family, this is the most important thing about that family, because let's say I drew a toilet, but I classified it as a sprinkler. All right, it's not going to work. It's not going to behave correctly. So this is the highest here, and this is like an example plumbing fixture. Okay, so that's the top tier. The tier below that is the family type. Okay, so you know what? Let's go with Okay, pipe fitting. That's the family category. The family type is, of this category, we can then create types such as an elbow, right? So an elbow is a type of pipe fitting, right? And it's one type. So under the category of pipe fittings, and you know how we can best exemplify this, is if we go to the project browser and we scroll to the bottom where it says families and expand on that, you'll see here, these are all the family categories, all right? If I go to my VV settings, these are also all my family categories. Okay, so this is why it's really important that when we create families that we classify them correctly. I'm talking theory here, and we'll get to practice very, very quickly. But this is important to understand. So then if I go to pipe, this one doesn't have any loaded, but let's see.
Pipe fittings?
Yeah, I don't have any in here, so it's not going to help me. Right.
Okay.
So, okay, so I'll just use this as an example. So ceiling is the family category, right? And then I have two types under there, a basic and a compound ceiling. And these are types, okay? So that's so that would be like pipe fitting and an elbow. And then the last is below that, call it I. Family category, family type, and then we have what are called the instances. Family instance. And so this is, I have this elbow in my arsenal, and when I drop one onto the sheet or onto the model, that becomes an instance of a family. So think about a fan, for example. When you give a fan a tag, right, you have 6 fans on a rooftop. Each one has a mark, EF1, EF2, EF3. Each of those is an instance of that family. They're all a centrifugal fan. They're all a rooftop unit. They're all a mechanical equipment, right? They're all those things as well. But on the most bottom tier is the instance, which is the one-time placed version of it. So this would be when we give it a tag, and it's a unique component. All right. So within these 3 tiers, you have different types of parameters that have to be built in. And what that means is, for example, that fan that we just talked about has a tag, right? That tag is EF1. The family type doesn't have that tag, right? Not all the fans are going to be EF1, but there is some information on the family type level that does need to be there, such as the make, model, manufacturer, right? Those specific types of information should be on this level, not here, right? Because they all have the same make, model, manufacturer, okay? But the instances will acquire that information, and then beyond that is the instance parameters that are specific to just that one placed item.
So the instance is every time it occurs, that particular item occurs in
yes,
the
is an instance. And there's instance parameters. So for example, if you really want to get abstract, a floor plan is a family itself. Okay, and then what we're looking at here are the instance parameters of this floor plan. Right, meaning what's the name of this floor plan? It's different than the other floor plans, right? What's the view range for this floor plan? It's different than all the other floor plans.
Yeah.
But on a high level, it's a floor plan like the other ones. It's looking down, and maybe some other information about it. So let's recap. The family category, when assigned, dictates where that particular family is placed here. And it's especially important for electrical stuff. Because electrical stuff, like let's say I make a duplex receptacle, okay? If I classify it as a nurse device, then it's not going to work like a power device. Or if I classify it as a telephone, teledata, then it won't work like this. So these are all we kind of understand that, what I want to do is create a duplex receptacle for use in this project. We don't have any loaded. I hope we don't. Yeah, we don't have any loaded. Okay. All right. So in order to create a new family, and families work the same way in Revit, as Revit projects, they are not backwards compatible. And it gets tricky because Revit families are also reusable, right? Meaning, like, when I create, let's say we create this duplex receptacle, I want to be able to use it in all my projects, whether it's a 2014 project, a 2015 project, a 2016 project. That receptacle is good for all of them, right? It's a receptacle.
Right.
So when we create new families, we create them in the oldest version of Revit. So that way, if I need it in 15, I can copy it out and upgrade it. But if I created it in 16, I couldn't use it in 14 or 15. It's a one-time deal. So let's say you're working on a 16 project, and an engineer comes to you and says, oh, you know, we don't have this in our template, but I need this specific VAV type or this specific pipe fitting, and we use it a lot. Don't create it in 16, even though that's where the project is. Open up 14 and create it there. Save it to our Revit 14 template family folder, and then copy it to the 16 project, right? So that we always now have a good one out there for us to reuse. But in this case, let's just say we're in 15. So in order to create a family, we go up here, we go to New, and you have to, you can't click on New because that'll default to Project. You hover over, and we go to Family. Okay, does everyone get here?
No. Mine went to New Family, Select Template File.
All right, so follow this path here, and that'll get you there. Does yours go here, Ellie?
It goes to English 1?
Yeah.
Okay.
English. Imperial.
Okay.
It's an I for Imperial.
Okay.
Okay? So in here, these are all templates of families. The same way we have templates for projects, there's templates of families. The first folder that you see is annotations, right? Annotations are their own family, meaning a tag, a room tag, a size tag. Those are all families as well. So even 2D line work is also a family. Title blocks, as you see here, those are families as well. So when we load a title block from an architect, it's a family that they created, and every time we place it on a sheet, that's an instance of that, right? But again, these are just templates. And what they do is that they come in with predefined things just to save you some time. But what I want to do, and what I usually do, is I go down to this generic model. And the reason is I use this template because there's nothing in it. And I like starting from scratch when building my families rather than using what they give me. Okay, so let's click on, you know what, before we get into this, let's go back to the agenda. Are you guys familiar with the hosting of families? How families are hosted in Revit? Or should we go over it again?
Might want to go over that.
Okay.
I remember hosting the family. It's better to use the host element in order to make sure that it's labeled correctly in the RTP, the ceiling grid.
Okay. Yep, that's true.
I'm not sure, is that the standard? Like,
It depends on the family. Like some families should be hosted and some shouldn't. All right, so this is a room. Here's a ceiling. Here's a wall. It's obviously a wall too. And then I'll leave it. Okay, and then here's the slab. So the way that Revit works is you can have elements that are hosted or not hosted. A non-hosted element would be something that doesn't have to detect anything. Let's think of, let's look in this room and see if there's anything that's not hosted. No. This entire room is hosted. So what would not be hosted would be...
Ductwork is not hosted. Right?
Correct. But we don't make duct families. Fittings, pipe fittings, okay? Pipe fittings, duct fittings, none of that. None of that is hosted to a wall or a ceiling. It's just floating in space, right? When you create a family, you initially need to determine if the item needs to be hosted or not hosted. And so mechanical equipment, most of the time can be hosted to the floor, meaning like if the floor moves up or down, then that also moves with it. But some things like air handling units are suspended in the ceiling don't need to be hosted, right? Because they're kind of just in the plenum or a VAV box.
Right.
So there's some things that do and some things that don't. The tricky thing about it is you can't go back and change that parameter. A lot of things in Revit you can go back and change later, but when you initially create a family, that is systematically something that you have to evaluate up front. Okay. Then to make it more complex, you can specifically tell families, not only do I want you to be hosted, but only to ceilings and only to walls. Okay, so like they need to find something that's classified as a wall. It will not be able to host to anything else.
Right.
Wall, ceiling. So things that can host to ceilings would be light fixtures, it could be sprinklers, speakers, anything that we see here in this room, we would want to be hosted to a ceiling. But the trick is that, do we model the ceilings?
No.
Okay. So then we don't actually have those ceilings in our model. So when I go and I place a ceiling hosted element in my model, it doesn't recognize the architect's ceiling as a ceiling. So it won't be able to place there. And it won't recognize the architect's wall as a wall either. So when we develop families, we never choose those options. The only option that we ever choose is face. This is the only hosting option that I will allow. And what face means is anything that has a surface, our hosted item can be hosted to it. It can be hosted here. It can be hosted here. It could be hosted to this chair. It could be hosted to the front of the TV. It could be hosted to the top of the keyboard. Anything that has geometry and a face,
right,
we can put it there. And that works because it'll treat that as a face. It'll treat that as a face. It'll treat this as a face. And if those faces move, meaning the actual ceiling moves, then our stuff recognizes that and moves with it. All right? And that's on a fundamental level. I can explain the benefits of or why there's wall and ceiling mounted devices, but it doesn't help us. So let's look here. Let's go back here and look. We have generic model.
Mm-hmm.
We have generic model wall-based, like I discussed. We have generic model two-level based, so that's something that that'll stretch like a column or something that goes from here to there. It needs two.
Mm-hmm.
All right. Roof-based, again, it has to find a roof, only roof. Floor-based, ceiling-based, face-based. Okay, so we always go with face-based when doing hosted elements. Non-hosted elements, we go with the generic model template. So we're creating a, what did I say, a duplex receptacle, right? Is that something that needs to be hosted?
Yeah.
Yes, correct. So we're going to go with generic model, face-based. And
Can you hang on 1 second? I'm sorry.
no problem.
Okay.
All right.
Yep.
When I toggle between these two thumbnails,
Mm-hmm.
you'll see that the generic model is just two crosshairs, basically. But the face-based one has this rectangle. So I'm going to go ahead and open this up. So go ahead and click Open on the generic model face-based.
Mm-hmm.
And I'm just going to go in my project browser. And you'll see here that in my family, there's this rectangle. This rectangle isn't actually part of the family. It's the face. Right? It's just a face for you to use as reference when creating this device. All right. It can be changed. Like you can change like the parameters of it, but it's irrelevant. It's just a face. And anything we want is going to either be flush mounted on here or maybe a little recessed in there, right?
So it's just giving you a point of reference.
Correct.
Basically.
Correct. Now, while we're in the family editor, let's take a look at the new user interface. Properties tab, palette is exactly the same, right? Project browser is exactly the same. Up here, not the same. This is where we start to get a little different. Let's go to the Create tab. And we'll see that we have, there's two main panels here that we're going to discuss. Forms. These primitive shapes are what we use to create the actual family. Okay, so we always wonder, like, how did somebody make that family? How did they make this chair in Revit? How did they make this mouse? How did they make that light fixture? It's a combination of these primitive moves. So the extrusion, for example, you create a shape, a profile, and then you pull it up or down, and it just creates a long version of that. A blend is, as you can see here, I want it to be like a rectangle on the bottom and a cylinder up top, extrude into that shape. So, for example, what would be a good,
Cup?
well, the cup is a circle. Yes, you're right, because even though these are two circles, this is a different size circle, right? So this would be a great
Or
example.
even your bottle.
Yep. Well, okay. No.
No?
Because we can't, this would be two extrusions. It would be one normal extrusion up here,
Right.
and then an extrusion blend here, and then an extrusion blend here. It seems like a lot of work. That brings us to the revolve.
Okay.
So the revolve is create a profile of something,
Mm-hmm.
and then revolve that around, like in pottery class, right? So that would be much easier.
Okay.
Make sense?
Yeah.
You do this side, and then revolve it around here, and that works when something's symmetrical about a center axis.
So when it comes to
And you
creating,
could even, sorry to interrupt,
Okay,
you
no.
could do it with this too, right? The revolve would work
Yeah.
this way too.
when it comes to creating these things, you're kind of on your own when it comes to how to do it.
Yes or no? Like, as you get better, you'll know right from wrong.
Okay.
Like in AutoCAD, there's a million commands to get the job done. We all know what the right ones to use are.
Right.
You could use the other ones. We know the pros and the cons. And I'm going to, the reason this class is very important is because in terms of content, we're always creating new content. We have a lot of the things already created, but we have a lot of things that we still need to make. And the reason is when we've been working in CAD for the past 15 years, we don't have any families for these things. We have symbols. We only have symbols for everything.
Mm-hmm.
And look at the 101 sheet. Look at all the things on there that we have: valves, elbows, strainers, mesh screens, diffusers, everything. So I've been creating everything, but there's still more. All right. So the duplex receptacle. I'm sorry. Let's continue with this. The sweep. Sweep is like an extrusion, except you can the extrusion is linear, meaning you can only extrude in one direction. A sweep is the same idea where you pick a shape and you pick a path. Okay? So think about I don't know, anything in here. Think about a neon S, right? Like that's got like a circular shape and it follows a path, right? That couldn't just be an extrusion straight up. Sweep blends are like a regular blend. So this could be like a pump. Like a pump kind of takes a different shape as it extrudes. And then a void is when we need to create a negative in a shape. So I would create this revolve, right? But I want this open. So I would create another, if I go to void, you'll see they have the same options for these, but in void form. So I would create one that's slightly smaller, right, in here so that I have this thickness in here. So I'd create this solid shape and then create one a little bit smaller that goes inside of here and remove all of it so that this is open. So that all I'm left with is this difference between them.
So it's also an example of a window and a door in this case too? Like,
Yep, everything in this room is a family.
okay.
Let's look at the window. All right, how would I make this window? The trim This would be a, you could use an extrusion, right? And you would
make the sill.
You would make the sill and then pull it out, right? Then the window itself, you'd have a lot of different extrusions in here. So this would be one extrusion, this would be one extrusion, this would be one extrusion. Okay, so there's a lot of parts that go into it. But what we're going to do today is basically our duplex receptacle, which looks like this, right? And what we're not going to do, because I don't want it, is we're not going to put the prongs in here. Nobody needs to see that. All right, we're not building that level of detail. But let's go over level of detail quickly, because this is an industry standard. You know what? I'm just going to Google it, so I don't have to explain it. So the level of detail, here we go. Nah, yeah, that's more like it. So a level, these are wrong. It should be level of detail 100. Okay. 100 is crazy basic, nothing.
Like head, right?
Yes. 200 gives you some shape, but and 100 actually doesn't include any of this. It's probably just office chair for 200. 300 is this, which is now looking a lot more like a chair, and we start to include a little bit more information. This is probably a 400 level of detail right here. It includes it's a higher level of detail and more information in here. And then the 500 is like this, where we get bananas. And this is for rendering purposes only. This is when, and I'll show you guys some amazing Revit renderings. These renderings were done with no post-processing in 3ds Max or any other program. This is straight Revit. It's a big image. But you can already see, like.
That's Revit?
Yes, this is Revit. This is taking a long while.
Looks like a photograph.
Oh yeah, this is actually one of the best ones I've seen. Damn. Okay. Yeah. So look at this. Look at the reflection here. Look at all this. This is Revit native, no post-processing. All right. Wow. So this is when you put the prongs in the outlet. You don't put the prongs in the outlet for DD issuances, right?
Okay.
All I need is something that functions correctly, meaning it hosts to anything I would tell, because there might be floor-mounted devices, there might be ceiling-mounted devices. So the duplex receptacle needs to be able to host all these things. It needs to have shape so that when I go into the 3D model, I see it there. And it needs to have the BIM. It has to have information behind it, voltage, circuiting capabilities. It needs to have the right family category so that when I place it, we could do a quantity takeoff and say how many duplex receptacles are in this project. So all of that needs to be built into visible and non-visible information. So for this exercise, we're basically just going to draw. I'll draw it in like side view, a back box, right? Because they all have the back box where all the circuitry goes, and then a faceplate. Okay. So that's what we're going to draw. Now, what do you think we're going to use for these? What kind of modeling?
Extrusion?
Extrusion only. We're going to keep it nice and simple today.
If a square or rectangle.
Two squares.
Yeah.
Right? This one and this one.
And then one up and then the other one up, right? Because they're sitting.
Well, we're going to get to how, like, there's, yes, the shape, the only form we're going to use is extrusion for this. If we wanted to, maybe if we have time, like, we'll look at the face now. A lot of times they're, like, slightly, right? They have that slight bevel.
Yeah. We
could do that. Now, how would that be done without using a void form? How would we do it? And I'll tell you why. Voids significantly decrease performance of Revit families, and when you place more of them, then your Revit project ultimately sucks. So how would we create, let's take a look at that thing on the wall, right? How would we create this exact shape minus the prong? I want this nice trim here without using voids.
Could you use geometry? supposedly this may be 4 inch, the inside may be 2 inch. Put it together, and then from there you go to the reference level and look at how it's.
Well, we have to do that anyway.
Okay.
But I'm talking in terms of actually implementing this. This would probably be a blend.
That's what I was.
Yep.
That's what I was thinking.
So we're going to go from
But
this outer shape to this inner shape.
I thought a blend was for two different shapes.
Well, like we discussed with this, these are the same shapes, but it would be a blend.
Okay.
Okay, blend as a picture shows two different shapes. Could just be the same shape, two different sizes, which is what this is, right? Just a smaller little front.
Mm-hmm.
Anyway, but that's
right.
What we're doing right now is practicing the critical thinking for creating families. But for right now, like I said, we're just going to do this, and if we have time today, we'll go ahead and trick it out. Okay. So what we want to do is before we start work, before we do anything in families, this is the most important thing to do, is specify the category of the family. You will forget later. You'll load it into the project. You'll click the button for electrical equipment. You won't see it as an option because we haven't specified this as an electrical fixture yet, right? And that's because we chose the generic model Revit template. So it comes with nothing. So how we do that is right here, this button. We click this, and this tells us the family category. We go to electrical fixture, and before we click OK, there's family parameters that are on this level that we're currently assigning. Meaning, so cuts with void when loaded. What does that mean? That means when I place this with the back box on the wall, it will cut a hole in the wall. And how does that help us? Believe it or not, people do quantity takeoffs on the amount of wall or material that they will need, and they will use Revit intelligently to subtract those outlets, right, because they don't need it.
So I have my filter list as architecture.
Show off.
Okay.
Show off. Part type, in this particular case, we only have 3 options, but for valve pipe accessories, it could be valve, fitting, such forth. So junction box, normal, or switch, this is just a regular normal category.
Sorry, I don't see show off.
You have to click each one.
Okay. I see it.
Okay. Ground connector dimension. Let's say this was an elbow. All right, the elbow that we're creating for pipe would need to be smart enough that when you drop it in, it picks up the size of the pipe that it's being dropped into. Is it going to look for the diameter, or is it going to look for the radius? That matters for us building formulas to make it reshape itself automatically. Maintain annotation orientation. Very big. Okay, and I'll explain to you why.
That's a way to keep the label no matter how you turn it or move it?
Yes. I chose electrical fixture in this case, specifically duplex, because it's a little more advanced than your standard family, but it has a key element in it. And this might get a little too deep. I might have to come back and re-explain it. What we're doing right now is we're building the actual geometry, right, what we just saw on the wall. How do we show duplex receptacles on our plans?
In AutoCAD or in Revit?
In AutoCAD.
It's just a symbol.
Right, which looks like 2 lines in a circle.
Yeah.
Right? This is our symbol. Duplex receptacle. How will this look on a plan? If I was looking down at a plan and I saw this, all I would see
A line.
is like, if this was my wall, that's what I would see.
Yeah.
That's nothing. That is not how anything should look on a plan. It will get overlooked. Guaranteed. This is not how we draw it. It's gotta look like this. There's a reason we use these symbols, right? Because they're loud, they're big, they're very easy to see. So we're building this family, but when we place it, I want it to look like this, right? this line work that we're drawing here is two-dimensional, right? It's not a 3D thing. It's annotative, meaning if I want it to be 1/8 of an inch from here to here, right? On the page, no matter what scale I'm at, it will always stay that paper size as an annotative object. So what we need to do is actually create a separate family for this. Just the symbols, just the line work. It's going to be a separate family. And what we do is we then insert that family into this family. A nested family inside of this family. If you do that, okay, so let's say that we're looking at the actual geometry of the wall, right? And then here's my little receptacle. If I place this symbol on top of that, it's going to look good that way. But what happens when I place it on a floor, right, or a ceiling? Like that annotation is always like this. So is it going to turn with the object, or is it going to maintain and always be visible? So this has to be checked. When we're creating electrical symbols or anything where we have nested annotations, then we have to check this box. I know this might seem crazy, but we're going to, in about 30 minutes, we'll have the whole thing complete. All right? The OmniClass number, OmniClass is like a third-party company or organization that gives crazy numbers to things, and what this is used for is estimating purposes. So when people run estimating software, they also use the OmniClass tables. So by us giving it this exact OmniClass number, when they do their whatever the hell they do, they can pull it from that number. We don't have to do that. That's an LOD 400 type of action. So don't worry about it. And then before we continue, just to verify, the host is face. Right? You notice that's grayed out? Because like I said, we cannot change that. You cannot change that once you start it. It's kind of like placing your Revit link origin to origin. You got to do it right the first time, and you got to do this up front. Because if you go down and make this whole great family, you can't even copy it. You can't even copy the stuff you did to another family. You have to completely start over. So we verified this. It's an electrical fixture. It's placed on face. It's all great. All right. So now what we're going to do is we're actually going to model this thing. So what we want to do is look at our project browser and see what we have here to work with. So what we basically have in every family is a reference level. And that reference level is always looking down. It's always looking down at the object. Now, this face, right, is horizontal. So we're looking down. Most of the time, that receptacle is going to be on a wall vertically. It doesn't matter. Because, right, like this thing, it doesn't matter. It's all relative to this face. So that's this. Ceiling plan, that's if we're creating things for ceiling hosts, which we're not doing, so irrelevant. 3D view is just a 3D view. And then you have your elevations, which you can see here on the view cube, which one is which. So front, right, back, left. And that's when we go into an elevation view to, maybe we want to do our extrusion from a right-hand view rather than from a top view, right? Or the revolve, we're going to want to do on a side view rather than a top view. The way that you orient this family is very important for when you bring it in, right? Like if you modeled it upside down and then bring it into the model, there's no way that you can fix that. So you have to always know, like, this is up, right, relative to this wall. So we want to place that fixture on this face. And what we're going to do is we're going to start from our reference level. So let's open up that view. And you'll see here two reference planes. These green dashes in Revit families and in Revit models are reference planes. They're non-model things. They're just reference planes. This one is the front back. This one is the left right.
On top of these laptops, you can't see the blue line that you on the screen. I can't.
What's the blue line?
When you hover over the green one, yeah. The laptops, I won't be able to see that.
If you select it, does it turn red?
Maybe I selection. I think it is.
Yeah, if you go to your user, your graphics, you can change the colors under graphics.
Okay, to red?
Yeah.
Yeah, it is red. That's a red, blue, orange, and then red.
Okay. I see them here. Oh yeah, you're not able to select them. There you go.
Okay.
Because they're pinned.
Oh, yeah.
And you had that on,
Okay.
which is a good habit. All right. So why do we start with these? Because these tell us perfect center on the wall, right? Which is also, you've created blocks before, right? Both of you?
Yes.
In AutoCAD?
Yeah.
So you know the insertion point. When you click a block, where is that symbol with respect to the tip of the mouse? That's this point right here.
Okay.
All right, so when we create this thing and we want to place it in the model, where do we want the mouse to be on that thing? Obviously dead center, right? We don't want the fixture over here, so when my mouse is here, it's kind of like that. Doesn't help anybody. Let's think about an air terminal, though. Okay, when you place an air terminal, you're placing it on a ceiling grid, right?
You probably want the corner.
So when I place it, if I was to draw my terminal like this, with that being the center point, then I'd have to find that stupid midpoint, like a sprinkler, where you draw a detail line, midpoint this. Why don't we just draw it over here, right? So that my insertion point is a corner. So then when I drop that block in, I just snap to intersection, and I place it correctly. So you don't always want it dead center. There's some things that we want offset. So we think about all of these things. All right. Now what I want to do is how do I create something that is perfectly centered around these axes? A couple different ways. But the first thing we want to do is start an extrusion. Okay? So let's go to the Create tab, click on Extrusion, and what you'll see is before you click anything, you now get this context box up, and it says, what do you want to draw? A polyline, a rectangle, a polygon, circle, an arc, right? Because you might want that extrusion to be all sorts of different profiles. We're drawing the profile of the extrusion. We might want it to be a circle. We might want it to be an arc with a tangent. In this case, we want, what do we want?
Rectangle.
Yep. So let's click on rectangle. But the problem is, like I said, like how do I know that my midpoint will be over each of my lines? Right? Meaning, like, is that centered?
No.
How do I know?
Well,
How do I know? Just like in AutoCAD, you're going to draw it out, and then you're going to move it. So just draw a rectangle, okay? If you see this pink in Revit, you're in sketch mode. You're drawing the profile, so that's how you know you're in sketch mode. So draw a rectangle, all right? You guys got them?
yeah.
Grab it.
Okay.
Okay. The command for move is MV, no enter. And what you'll see is two midpoints. Like this is my horizontal midpoint, and this is my vertical midpoint. It tells you already. So I'm going to zoom into my top one here, find that midpoint, click it, and drag it over so that it intersects with that, right? And then I'll do the same for the vertical. I was pretty close, but never perfect. Okay? You're only getting the one. See, when you draw a rectangle,
Yeah.
actually, it creates 4 segments.
Oh.
So you got a box left. Yep, there you go. And then MV. There you go. Good.
I did the first one already.
Okay. Did you get it, Ellie?
Yeah,
So there's no, in Revit, there's no, you don't activate the commands.
No.
Once you type them, they're
No.
Okay.
So you want to move all 4 of these, right? Yep, there you go. And then MV. Good. Yep. Well, see what you did there was you didn't you moved it this way and also up. You wanted to just move it left and right. You see? See how it moved up as well? So go ahead and grab the box again. Okay, MV. Okay, good. That's not the, that's just the perimeter. It's that red. Yeah, there you go. That. There you go. Perfect. Perfect. Okay, and you did the other direction too?
I believe so, but maybe it moved.
Okay, MV. You have them selected. No enter. Just MV. You already have them selected. So MV. Yeah, that's good.
I was just thinking, when we do this exercise, can we use the align, AL?
We'll get there. Not for that. Not for midpoints. Okay. Only for parallel planes.
Okay.
All right.
So I just got a cat mode.
You gotta have like two brains.
Yeah.
So when we're done with the profile, what we're gonna do is we're gonna click finish. Okay. And what that does is it finishes the plan. So let's just go to our 3D view and take a look at what it looks like now.
I see a box.
You made a box.
Yay.
You made it. We're done. You got your box? Come on, man. Can I make a box?
No, I got it. I'm just trying to. I'm in 3D.
Oh.
Uh-oh. Not a problem.
That's not right.
That's right. That's right. Finish the wireframe.
Still not right.
It's in the wall.
Inside the wall.
Good question. I want it inside the wall. This is going to be our back box, right? The back box goes in the wall.
Oh.
But you didn't mean to do that. I know.
Yeah, I did.
Nope. Okay. So I'm going to orbit around and take a look. Looks amazing. We've made this amazing rectangle. I want this one to be inside the wall because this is going to be the back box. What? Okay. So pick any one of your elevations. And what this does is it now lets us look here, right? So you have an elevation?
Yeah.
That's weird.
You good?
I mean, I have an elevation, but okay, I'm just trying to see what I'm seeing. If mine is actually inside the wall, why does my elevation look like that? Shouldn't this?
Oh, okay. Well, then maybe we're not looking at this correctly. Yeah, this is upside down. Look at your view cube. You see, you're upside down. So you're seeing this, and it's here. So we can flip you back. You meant to do that, though, right?
Sure.
Okay. So let's go to our elevation view. And this is where I'm going to be able to use the align command. All right? We're going to use it a few times today. The first thing I want to do is select my extrusion. And you'll see when you select it that you get 4 grips, right? Those grips allow us to stretch it in any one of these planes. So we can make it taller or we can make it wider. The one plane that we're not able to do, right, is the way to make it go this way, because we're not, so I'd have to switch to a left or a right to change it. Or I could be in my reference view and use the grips from there as well. But right now, all I want to do is focus on the depth of this item. So I'm going to take this bottom grip, drag it down. We're not going to be exact right now, just into the wall. And now I want to have this back box be flush with the reference plane, right? So let's use the align command. And we're going to pick the static object first. In this case, it could be the face. It should be, let's pick the face as the static. And then we're going to pick the top of the back box. And when we do that, now it's perfectly flush. Right?
Okay.
Did you guys get a padlock?
Yes.
Do I lock this?
Okay, so the padlock, no. The padlock is what is called lock aligned. And what that means is if this moves, the thing we just aligned will move with it. That padlock doesn't mean it's fixed in this location. It means it's locked to this plane now. So if that stretches, this also stretches. And that's how families become more dynamic. This is the first of many ways that they become dynamic. So we're not going to lock a line yet. All right. Let's go back to our reference level. And we still see it, right, because it's flush with the top. And now I want to create the faceplate that goes on top of that. So we're going to create another rectangle that's slightly larger. That's like out here. Okay. So do the same thing. And before you guys do this rectangle, remember how we created a rectangle and we guessed at perfect midpoint? Mm-hmm. And then we had to move in both X and Y later. So let's try something different. I'm going to take this, while in the sketch, I'm going to take a single line, and I'm going to draw it here, like this, okay, just like that. And then I'm going to use, I'm going to select it, type MM, which is the mirror command, and mirror it here. So what does that do? That guarantees that these two are perfectly equidistant, right, from this line.
I forgot how to.
You went a little bit too fast.
Sorry, guys.
We go to create.
So we'll start over. So create, extrusion. This time instead of, just watch the screen. Okay. So instead of going with the rectangle, I'm going to go with the regular line. Okay. Okay. I'm going to draw it out here. Close out that command. Then I'm going to select that line and mirror it using MM over here. Okay. So you do that up there. And then I'm also going to do it in the other direction. Like that. And you should end up with something like this.
Mine went out about the line.
Oh, because you used the wrong axis then. Okay, so let's, all right, so show me what you did. Yep. So what's the axis line? That's it. Yep. There you go.
Okay. I think I might have touched the
Exactly. Another one, and that created a different center line.
So then,
and then create another one that's horizontal. And then we're going to use another modification command to make this a perfect rectangle. Now, obviously, this isn't the easiest way to do this, but I'm using it to teach you additional functionality. All right, so Ellie, you have your two horizontals now, too?
Yeah.
Okay. So what we're going to do next is use the trim command to just trim up. TR is the trim. And you just pick these like fillet or chamfer, and you just pick these items and trim them together. TR, and then pick two items. And the command is sticky, meaning you can just keep clicking. Good? Okay. So you can see there was no moving to a line. We know everything is, the midpoints are perfect because we use the mirror command. So we use symmetry to help us here. But maybe just drawing a rectangle and moving it would have been faster. But this comes in handy a lot. So let's click Finish now that we have our plate. And now we're going to go back to an elevation view and see what this looks like. Okay. This plate is way too thick, right? These things should usually be very tiny, like that. So I'm just going to change the depth there to that. And I'm going to go to my 3D view. And now let's take the placeholder wall face thing, select it, and then type HH to hide it. Okay, so now we can just take a look at the full item. So this is what we created today. Nothing amazing, but it's a simple thing that will work. It will get placed on a wall, the back box will be in, the plate will be on front. We created it, classified it as an electrical fixture. All right, now there's a couple more things we need to do. One, we need to give it a voltage. We need to give it actual information. Because in Revit, this thing gets circuited to a panel, right?
mine looks different.
It's not going to look exactly the same, but basically two rectangles, one bigger and thinner.
Will it come out later?
Yeah, like, oh, so what I said was to hide the face, right? See? Okay, so now what we need to do is add electrical information to this. Just saying it's an electrical fixture isn't good enough. We need to add that information. So let's go back to the Create tab. And you'll see that we were just working here, right? This is the second part of it. Whenever you create something in Revit, in order for it to interface with the rest of the project, it needs to have these connectors, one of or more. If you think about a condensing unit, it's going to have electric power, it's going to have air ducts, it's going to have condensate pipe drain connections, it's going to have all of that stuff. So some have all, some have some have one, some have none. Some things don't have to have any. This table, chair, easel, right? TV has to have connectors. So we're going to create an electrical connector. All right? And it's going to ask you where you want to place it. Always place connectors in 3D in a family. Never place them from a 2D reference level front back. Always place them in 3D. Okay? In this case, just to make sense, I'm going to put it on the back of the back box, right? Like, just kind of like, that's where a connector should be. So I'm going to click right there. Good? Good? Yep. Nope, you have to see a blue outline, so click near one of the edges. There you go. Perfect. Hit escape twice. Close out the command. We've already placed our connector. And now what I'd like to do is we have to give some information to this connector. So let's select the connector. And you'll see with that connector selected, here's all of the electrical information. So we don't have to be electrical engineers to know, but this is, if we look here, the system type. Is it data, power, telephone, security, blah, 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 all of these different things. We could be creating all sorts of things right now. But this is going to be unbalanced power, and the voltage is going to be 120, and the load is going to be 180. Okay. So now what that means is when we load this into, bless you, when we load this into Revit and we place this on a wall and it gets placed on a panel, it's going to circuit correctly. If this wasn't done correctly, the whole thing is irrelevant. These guys don't care what it looks like at all. They care that it works in the panel schedule and then that it looks good. So we haven't done this yet. This will be the last part of today. All right. What we're not going to go over today is how to make these things parametric. Meaning, like, you know, when a pipe elbow changes size automatically, how does that happen? There's a lot of formulas that go into it, and they're all linked to the geometry. And maybe we'll get to that if we do round 2 of this, like maybe advanced Revit class. All right. So what I'd like for you guys to do is to save as this family on the desktop, and it's going to be E duplex. Okay. Call it E-duplex. Good? Cool. Leave it open. We're going to create a new family now for just this symbol. So let's go back to the R, new, family. And now you'll notice that there's a folder here for annotations, right? Different than generic models, different than these. These are real geometry. These are annotations. So let's go into the annotations, and we're going to go to generic annotation. Click open. Okay. Delete this note. And now what you'll see is the same crosshairs, but what we don't have are any views. Why?
Because it's not geometry.
It's not geometry. It's just line work, right? There's no side view. There's no under view. There's no 3D. It's CAD, basically. 2D line work, Nothing else. Let's go to the Create tab. What do you see here? No forms, right? Just line work. We're creating lines, maybe some text, maybe a hatching region of some sort, nothing else. This is just line work. It's perfect to make this guy. Okay? Now, either of you guess what height a duplex receptacle is on paper space? Duplex receptacle, size on page.
3 inches?
Oh my goodness!
No, that's way too
on a
big.
page?
I don't know. I'm just.
A duplex receptacle would be this big.
330 seconds?
330 seconds.
Okay.
Fine. How do we guarantee that? Because when we were making those sketches before, we were eyeballing everything. We gave no dimensions to it. I want it to be exactly that. So what we do is we create an additional, like, let's call it reference line, and set that reference line to 330 seconds, and then align our actual model lines to it. Okay? This command creates these. This command creates nothing that gets plotted. This is a reference for us to establish what 330 seconds height is. So let's start with that. We're going to create reference line. Draw it wherever you want to draw it. I don't really care. And the reason I don't care is because when you close out the command and select that line, this gives us our temporary dimensions, and we can input that information in right here. So what I'm going to do is select that line, hover over the vertical size, select it, type 3, 30 seconds with the inch symbol designation, boom, brings it in there.
That is tiny.
Yeah, well, because we didn't zoom.
What did you do again? I'm sorry.
Yep, you got it. And then hover over that field, left click in there. Yeah, left click, not right click. There you go. And then type in 330 seconds of image. Cool. Okay. Now, just as a side note, let's go back to the actual geometry that we just created, which was that back box and that faceplate, right? I'll tell you right now, the one that we created, yeah, that's way too big, right? This is 2 feet this way, so it's 4 feet. Okay. This is
Like the size of a panel.
Yeah, 4 feet by probably another 4 feet. So we did not create these the right size at all.
Right.
How would we create these the right size? The same thing we just did. We would have created a reference plane, probably 2 inches on this side, 2 inches on this side, 2.5 here, 2.5 here. When we created the sketch for the extrusions, would have used those reference planes. Okay. So I didn't explain it then because we were focusing on just creating that element. But when we need to make exact sizes, we use reference planes. I'm back in that other model we created. If I go to the Create tab, you'll see reference lines and planes here. So I could have created something here, right, and said the same thing. I want this to be 2 inches. And now we realize, wow, that thing is way too big. You have no scale when you have nothing on the page. Okay, so we're not going to worry about that right now. Let's go back to our family. So I'm going to zoom in. This is at 330 seconds. How wide should we have this thing be? 16th? 16th on either end would be an 8 wide?
Yeah.
So you both know, Revit, AutoCAD can go infinitely small, right? You could zoom in, zoom, draw tiny, zoom in more, draw even tinier. This has a limit of 3/32 of an inch.
Okay.
Okay, meaning we can't draw any smaller than 3/32 of an inch. I see that. Okay. So no symbol is ever going to be smaller than 3/32 of an inch. What that also means is, let's say I draw this line here, okay, and I move it. You'll see that no sign at 1/256 of an inch. I can't draw anything or modify anything under a 32nd of an inch. I can't move something a 32nd of an inch over. Okay, so let's say I did need to move it that far. I'd have to move it out here and then move it back, including that 256. Does that make sense? It's kind of a pain. It's a big limitation. Nothing you can do. Okay, not CAD. So let's create another reference line out here. And we'll set this one to, you know what? Yeah, we'll set this one to 1/16 of an inch. Okay, and then let's mirror it to the other side. Okay, so this gave us, that looks funky. That's not going to be a good one. I don't like it. How about 30 seconds of an inch? Okay, make it 1/32 of an inch.
I got kicked off.
What do you mean?
It says it's reconnecting.
There you go. Okay. All right, Ellie. So I made this 1/32 of an inch. 1/16 was too wide for the symbol. The proportion wouldn't be correct.
So 1/32?
Yes. And then mirror it to the other side. Good.
It disappeared after I type in 1/32.
Okay. Mirror is right?
Oh, you're too far out. Zoom in. Zoom in. No, just zoom in. Zoom in more. Okay.
But I thought we were supposed to draw another line.
Yeah, but you want to be in close. Okay, so go ahead and draw another line. Yeah, it's slow. There you go.
So I
Shape out. Not that. I want the distance from here to here to be 1/32. Good. And then mirror it to the other side too. It's going to be the vertical line. Good.
It's like it freezes.
Yeah, there's a serious line here.
Thank you.
Okay. So now what we've done is we've created the framework for us to then go and create the symbol. Now we know how big, how small, we have our bounding area, right? Okay. So what I want to do is let's start with, we'll start with the two vertical lines. So we're going to go to the Create tab and click on Line. And we're going to draw it from here to here, just that intersection. Good? Mirror it. So now we have the two legs. And then the last piece is the circle. So we're going to go back to, I know it doesn't make sense, but line. And then here we're going to go to circle. We're going to place it anywhere on that line. And we're going to draw it out. This is not looking right.
No.
We're going to have to fix it. See, we were just guessing at those numbers. That's fine.
Can we use the horizontal line as
No. There's a reason why not. When, if you were to use the horizontal as something, then that would change the way that this comes in on the wall. So like if this is my wall, I want it to be out here, right? But if I place it any lower, then I'm going to get it in the wall.
Okay.
right? This is the end of the wall right here.
All right.
Okay, so modify it a little bit, move it around. You know what it should look like. You happy with yourself? I can see that. You're like way too happy about this thing.
Yeah.
Perfect. Amazing.
Really.
Great. You guys have done an amazing job. Drawing two lines in a circle. It's like a basic AutoCAD class all over again.
I put it on Facebook.
Okay, go ahead. Be live tweeting this whole thing. All right. How about you, Ellie? Looking good?
The one going up, should it stick out like yours on top?
I don't know. I'm just being crazy.
It looks like the circle is bigger than the.
Yeah. So what I did was I moved the circle up. So select the circle, MV, and then just move it up. Keep going. See, that was not enough. It was too small. Remember I told you can't move anything under a 32nd of an inch? You had to move it more than that. Good. There you go. Good. And then extend these. Yep. So take one of them, and then use the grip. Just drag it up. Yeah, I mean, you know what it looks like.
Yeah.
So just make it look like it should.
Okay.
A little bit of creative thinking here. All right. So the last thing we want to do, well, not the last thing, but the next step is to go and save it again. And we're going to save it as a family on the desktop. Now, here's what we do. Specifically for components that have physical geometry as one family and an annotation as another family, is the physical geometry gets whatever name we're going to call it, and the annotation gets that same name and anno at the end. So that way I know these two guys work together. These two guys should always be friends. Okay? Save. Okay. Now what we're going to do is we're going to load this into the receptacle, and we're going to place it so that it works. So what we do from here is we go to the Load Project button at the upper right, and it's going to say, where would you like to load this? Because we could load this directly into our project, meaning there's no geometry, there's no electrical connector, it's just a straight up symbol, like a new connection symbol, a break line symbol. You can load it right in and use it today, but it's not ready to go, right? So we have to load this into our duplex family. Click OK. And does it bring everybody back to a reference level view?
Yeah.
Yeah.
Awesome. We don't want to place this anywhere else. This is where it gets placed. You can see that the size of it, so remember this is like 4 feet, right? So 1 foot, 6 inches, 3 inches. This thing is way too big right now. Why? What's my scale? Half inch.
Half inch.
Okay, so it's working. The reason we make it in that other view is there is no scale there, right? Like it's that paper, it's already annotative. When we create annotation stuff in AutoCAD, it's a little more like weird. This is just straight up, what size on the page, that's it. Really slick. And you'll notice, where is my insertion point? Right in the middle of that thing, because where did we place it when we created it, right? This is where we want that insertion point. We don't want it here, here, here. Perfect. And now we're going to place this sucker right here, dead center. And then escape twice. Okay? Good?
Yeah.
Excellent. Since we've just made a change to this family, let's go ahead and save this family again, eDevice. You can just click the Save button at the top. It's going to save over it. Okay? Awesome. And now we're ready to test it out. I already know that there's problems with this thing, but I want to see it work. So let's load this into the project. And again, what are we picking? Project 1. Click OK. Okay. And now we're back at a floor plan. Right? Floor plan? Floor plan?
Floor plan.
Let's go way back to when we first started this class and we talked about hosting. Things have to find a face, a host of some sort. When you click face, when we created that family and said hosted but by face only, you'll notice that right now I am not able to place this thing, right? And that's because it's looking for a vertical face. So it doesn't have to be a wall, but it's only looking for a vertical face. So when I take my mouse and I bring it over here, boom, right? Boom. Not up here. What about on regular face? Now I can place it on the floor. I can place it on the wall.
Yep.
I can place it wherever I want. But the difference is, you see, when I'm placing it on the wall here, when I'm doing place by face, that back bot, like it's not hosting correctly.
Right.
When I click on vertical face, yeah, that's correct. So this is something that can't be avoided. Everyone here has to know, like, that's just the way that these things work. That's just the fact of life. Because there's floor boxes, there's poke-throughs, there's wall-mounted ones, there's ceiling-mounted ones. So you just have to be smart. This is part of Revit. You have to be a better designer. You have to know these buttons. So vertical face, and I'm going to place it right here. You guys get that? Did it work? It worked. It worked.
Yeah.
Okay. The back, I mean, we can tell this thing is, the scale's terrible.
Yeah.
It looks awful. But we made it work.
Because in this view, we shouldn't even be able to see all that.
Yes. Yes. But I just wanted to make sure at a minimum it came in, and what's this?
That's the information.
Yeah.
Yep.
Yep. Okay. So the last thing is, let's make sure that we made the family category correct. I'm going to go to device, and I'm going to go to electrical fixture. And it should be right here, meaning that it is an electrical fixture, right?
Mm-hmm.
Okay. I think we learned enough about families for one day. We'll definitely do families again, because unlike project-specific work where I say, hey, I have some ductwork I need you to route, I always have families I need made. All right, this is obviously a terrible family. But I always have families that need to be made. I always have symbols that need to be made, right? Like this receptacle that we just made, the single line work. I probably have 100 things on deck that need to be made right now. Symbols, families, you name it. So it's, you know, it's not something that makes us any money. Like, it's not project work, but it needs to be done. Just like blocks needed to be made at some point. So I think you guys did good. Families are not for everybody, but we made it work. So congratulations, your first family.
Thank you. So how it looks like, should we check it out in 3D when?
Yeah, why not? Let's check it out in 3D. So I'm going to go to my 3D VV, turn off my Revit link, because that's everything right now. There it is. And you know what's nice? You don't see the symbol, right? Because that's only 2D line work. Yeah. There it is. Whee! We did it. Let's render it. Oh, yeah. That's great. Good job, guys. All right.